What if the world that we know is merely a shadow of a much larger, more complex universe? In the early 1900s, Albert Einstein developed the theory of special relativity, and in doing so, he challenged a concept that's fundamental to our notion of the universe around us. He challenged the very notion of time itself by developing the concept of time dilation. Today it's my goal to demonstrate to you what time dilation is and to provide just a little bit of experimental support for time dilation. In effect, I hope to show you how the world is a much more complex place than we give it credit for. So let's begin by describing what time dilation actually is. In essence, Albert Einstein said that the faster you move through space, the slower you move through time. But it turns out that the effects of time dilation really aren't observable unless you're moving incredibly fast. In fact, even if you're moving 100 or 1,000 or 1,000,000 meters every single second, the theory of time dilation simply won't apply to you. You have to be traveling at about 10% the speed of light. That's 30 million meters every single second in order to really experience the effects of time dilation in a significant way. Once again, time dilation basically says that the faster you move through space, the slower you move through time. Now, I understand that this concept is incredibly crazy, or it might sound really just outlandish. You might not believe that this effect even exists, but it turns out that there's an incredibly impressive body of experimental support for time dilation. For example, in one experiment, scientists synchronized two incredibly accurate atomic clocks. They took one of these clocks and they put it into a space shuttle that was orbiting the Earth at about 7,700 meters every single second. Now, like I said before, that's actually not very fast when you're talking about special relativity and time dilation. But it turns out that the scientists were able to predict that the clock, every single time that it orbited the Earth, would lose about 1.8 microseconds of time. So every single time this clock orbited the Earth, it would lose about 1/50th of a hundredth of a second. But with these incredibly precise clocks, they were able to measure this difference. And they were able to obtain incredibly precise and accurate results in support of time dilation. So today we've taken a brief preliminary look into special relativity by describing time dilation. Furthermore, we provided a little bit of experimental support for time dilation. And with these things in mind, I think I can safely conclude that the world is a much larger, much scarier, more complex, and beautiful place than we ever knew before.